Hello students, welcome to Adankkal. Good evening to all.
Good evening, sir.
Good evening, sir.
Good evening everyone.
Good evening, sir.
Good evening. So we were discussing the degrees of freedom for different kind of gases. So now let us have a generalized formula which can be applied to any type of gas. So polyatomic gas molecules. If the gas molecules are polyatomic. So a polyatomic gas, it has how many degrees of freedom? Let us count. A polyatomic gas has 3 translational degrees of freedom, 3 rotational degrees of freedom, of course, and a certain number of vibrational degrees of freedom. That will depend upon the number of bonds. F vibrational, okay, of vibrational modes or degrees of freedom. So U will be F translational by 2 kT, F rotational by 2 kT, plus F vibrational into kT. It is for one molecule. Am I right? So now F translational, they are 3. Rotational are also 3. Vibrational, they are FV only. So it will be 3 plus FV kT for one molecule and 3 plus FV Na kT for 1 mole equal to 3 plus FV RT for 1 mole. Please check. Is it clear to everyone?
Yes, sir.
Now from this information we can get CV and then CP na? And it means we can also get their ratio. Okay? Clear? So CV du by dt. So 3 plus FV into R, and we know that CP is equal to CV plus R. Yeah. This is the general formula.
सर वाइब्रेशन में F/2 होगा ना?
Yeah. No, it's not F/2. Yesterday also I said na that each vibrational degree of freedom it constitutes kT energy. It's not half kT, it is kT.
Okay.
Now let us have a generalized formula, a more easier than this. Suppose for a gas, U is F/2 kT, okay, for one molecule, and for 1 mole, so CV is F/2 R. It means CP will be F/2 plus 1 into R. So gamma will be so this is the more generalized formula, important one. You can mark this important shortcut. So now with the help of this formula, I will calculate the number of degrees, not number of degrees of freedom, gamma for various gases. F is degrees of freedom. That's why it is F/2 kT.
Excuse me, sir. सर इसमें फिर अपन वाइब्रेशनल का नहीं लेंगे?
Yes, इसमें वाइब्रेशनल का नहीं है, बट अगर है भी तो उसको आपने ट्वाइस कर लिया है. You can always double the number of F na, for vibrational if you want to include it into the expression, just as I did yesterday. So these are total. So you can straight away calculate gamma from F. It means now for monatomic gas, what is F according to you for monatomic gas?
3.
So gamma will be, this is the same value we got yesterday na?
Yes, sir.
For diatomic gas, 5 for rigid.
5.
So gamma will be
1.5.
7 for non-rigid. You can see I have made it 7 now na, instead of 6.
Yes, sir.
How much? Same as yesterday na? 7 for linear.
Yes, sir.
Again it is 9 by 7 then. And for non-linear, it is 6, na?
Yes, sir. Sir.
So what is gamma? 1 plus 2 by
1.33.
1.33. Please check everyone. So this way you can remember, and this is very handy for examination. Again, important one. No need to do it in detail. Just remember f and this formula, gamma equal to 1 plus 2 by f. Clear?
Yes, sir.
Total translational at the same, it should be at the same volume at pressure is. For monatomic, it is given, and you have to get it for diatomic. Very simple. No, Rita, it's wrong. Read the question carefully. Very good, Himashi. Very good, Rima. It's wrong, Arun. I know most of the students will get this answer that you have got. Very good, Prachi. No, Ramjal, it's wrong. Very good, Yash. No, Abe. Very good, Humira. What happened? All the girls are giving correct answer and all the boys wrong answer. What happened today? No, Jasvi. Okay, let me give you the hint. Very good, Aruna. You have to get the only translational kinetic energy of diatomic, not the total one. And what most of you are doing is you are calculating the total one.
Yes, sir. Mistake.
For diatomic, translational degrees of freedom are 3. And for monatomic also. Of course, for monatomic, total degrees of freedom are 3. So it means translational kinetic energy of diatomic will be equal to total energy of monatomic. So they both will be same. Okay. For monatomic, F is 3. For diatomic, F rotational is 3. So therefore, rotational kinetic energy of diatomic molecule equal to total energy of monatomic.
The translation.
Oh,
The translation.
it should be translational, not rotation. Translational kinetic energy of diatomic molecule, total energy of monatomic. Either you can write at monatomic atom because it is not a molecule then. So it means it will be same 3 by 2 PV. That's it. Clear? Or should I explain it further by writing PV equal to RT and all? Is there a need? So such questions are there in EYQs also. I think they are there to confuse you people. So please read the question carefully every time you get this kind of question. Now another one. Consider oxygen gas at room temperature and pressure, and assume that only translational and rotational to the specific heat if Cp and Cv denote respectively specific heats at constant pressure and volume. This one. Very good, Prachi. Very good, Rita, Divya, Sanju, Arun, Kapil, everyone. Very good, Imanshi, Tamya. No, Gomti, it's incorrect. Yes, Sidesh. No, Jasri. Abe, it's correct. Tanushree, Uzma, everyone. Good. Good, Rima. So it is 7/5. Because it is clearly being said that only translational and rotational degrees of freedom they are contributing, and oxygen is diatomic. First of all, it is diatomic. Na?
Yes, sir.
And for diatomic, and also they have mentioned that translational and rotational they have to contribute. So F will be 5 na? Because it is diatomic. 3 translational and 2 rotational are there. So gamma is 1 plus 2 by 5. That is 7/5. That is the answer. Clear? So simple. Very good, Pachi. Very good, Divya. Very good, Yashri. Good, Ramdiyal. Good, Humera. It's wrong, Himanshi. It's wrong, Monirul. Yes, Sidesh. Very good, Rima. Very good, Arun. Abe, it's wrong. Now see, it is 2D. Na? Clearly, it is given on the 2D. Means this is a sphere. The particle is moving on the surface. It cannot go down and it cannot go up. So it can either move forward or backward or to the left or to the right. Only 2 degrees of freedom are there. Okay. For one particle, 2 and 4 n particles. Therefore, U is F by 2 kT. That is 2n by 2 kT. That is n kT. That's it. That was the trick. Okay. It is moving on the surface of the sphere. So obviously it cannot go down or up. No? Surface, it is a plane. It is 2D. So only 2 degrees of freedom are there. Clear?
Yes.
So be careful. A vessel contains now this one. Take your time, be careful, okay? No need to be in hurry. Very good, Siddesh. Yes, only one answer till now. Yes, Jayashree, correct. Good, Arun. It's wrong, Kapil. Very good, Divya. Wrong, Jayashree. Akhilesh, Gomti, Humera, it's wrong. Kapil, it's wrong. Prachi, it's wrong. Akhilesh, wrong. Very good, Tanushri. Kamya, wrong. Himanshi, wrong. Very good, Rima. Yes, Jayashree. You are not reading the question carefully. Those who are getting the wrong answer. I'm telling you again and again. And you will do this mistake in exam also this way. Very good, Monroe. Average rotational energy per molecule you have to calculate. So will it depend upon the amount of the gas? Very first question. If you have to calculate average energy per molecule, will it depend upon the amount of gas? I don't think so. You have to calculate the energy per molecule. It means it will not depend upon the number of moles of each gas that are present. And both are diatomic. And both are having same rotational degrees of freedom. So ratio should be 1 by 1. Na? Okay. So both the gases are diatomic and have same number of rotational degrees of freedom. Because we have to per molecule means for one molecule. It will be independent of amount of gas. So ratio is 1:1. Please check, is it clear? Yes. Got it or not?
Yes, sir.
Yes, sir.
Very good, Sanju. Very good, Arun, Rita. Yes, Siddhesh, good. Yes, Monroe. Very good, Jasri. Prachi, Kapil. Yes, Divya, good. Yes, Tanushri. Good, Smriti Shri. Yes, Jasri, good. So similar to the previous question, again, because we have to get the translational kinetic energy. Translational of O2 is given and translational of N2 we have to calculate. And the temperature is same. The only thing it depends upon is the temperature. Because degrees of freedom are same. Only if we change the temperature for nitrogen, this energy, it can be different. But if we have to calculate it at the same temperature, it is going to be same as that of oxygen molecules. Isn't it? Because it is 3/2 kT. Na? For translational, it is 3/2 kT. Na? And temperature is same. So for both, it is 3/2 kT. Okay, clear?
Yes, sir. Yes, sir.
This one is from RTJ. It's wrong, Siddesh. Wrong, Sanju. Very good, Usma. Very good, Rita, Arun. No, Rita, it's wrong. Rita, Arun, Prachi, it's wrong. Very good, Divya. Ram Dayal, Himanshi, it's wrong. Away, it's wrong. Yes, Yashri, Tanshri, correct. Samruti Shri, it's wrong. It's wrong, Away. Try to recall the yesterday's lecture. It's wrong, Rima. In yesterday's lecture, when I defined the degrees of freedom, I gave you the idea about this. It's wrong, Jasri. Wrong, Tanya. Yes, Gomti, correct. It's the option. It's wrong, Mera. I said that each quadratic term in the energy, it corresponds to 1 degree of freedom. So how many degrees of freedom are there? 1, 2. Okay. So 2 degrees of freedom are there. And energy associated with each degree of freedom is half kT. So for one particle, let us calculate for one particle. This is also a way to represent the average by putting the variable in this sort of bracket. And what is the average? Half kT plus half kT, that is kT, according to equipartition theorem. So for n particles, we have n kT. Why, Siddesh? 1D doesn't mean that it can only have one kind of motion. 1D means only one direction is accessible.
Yes sir. तो F equal to 1 होगा ना?
कैसे?
जब 1 डायमेंशनल है तो
Even your
और अगर वन डायमेंशनल है तो कोऑर्डिनेट एक ही तो कोऑर्डिनेट है जो चेंज होगा टू डिफाइन पोजीशन.
But here we are having potential energy also. You people are thinking about the moving energy only, and that is kinetic energy only. You are talking about this energy only. What about this energy? This is not associated with motion. Even if the particle is at rest, then this energy will be there, corresponding to some value of x. Just as you have in case of a spring. Think of the particle attached to a spring. Now, let me make you the diagram. This is the particle. It is capable of moving only in 1D, but it is having both energies now. Potential because of the spring and kinetic because of the motion of the particle.
yes sir.
But you are not considering this energy. You are considering the particle only, that it is only one variable is changing. Clear now?
Yes
Yes sir.
Each quadratic term, it means it is 1 degree of freedom. So 1 and 1, 2 degrees of freedom are there. Now, next one. A system of n classical non-interacting particles no.
Sir, what is D option?
No, non-interacting means there is no potential energy because of interaction. It is not related to rigidity or
Sir, what is D option? N root A upon M.
log natural kT upon m. It is ln log natural. That's why they are saying that they are confined by the external potential. So their own potential is 0. They are not interacting among themselves. The only potential is the external potential. It means the particles, they are only having kinetic energy. That is the hint from my side. No, no, Tanushree. No, Rita. It's wrong. It's wrong. It's wrong. Very good. They are not interacting with each other, but obviously they are interacting with the external potential. Na? Only then they are getting confined. So that will also contribute some energy. You are forgetting about that. It's wrong, Ramdya, Uzma, it's wrong. Then what is the use of external potential? Yes, Tanya, it's correct. Exactly similar to the earlier question, but now the thing is, here the energy is in 3D. P square by 2m, the kinetic energy of the particles, and potential, this half r square. Now, can I write this as px square plus py square plus pz square by 2m plus half a x square plus y square plus z square? So how many quadratic terms will be there? 6, huh? 3 from the momentum and 3 from the position coordinates. So f is 6. So this shows E is equal to half into n into 6 into kt. So this is 3 n kt. Or you can write in this way, 6 into half kt. This is much better. So A option. Check everyone. Clear? Is it clear?
Yes, sir.
If molecules are also interacting among themselves, then it will further add up to this energy. In low density oxygen gas at low temperature, yes. Yes, Siddesh, Monirul, Arun, correct. Yes, Uzma, Rita, Jashri. Very good, Divya. Yes, Tamya. Clearly written in the question. No need to think even. Clearly. It is diatomic and they are saying that only translational and rotational modes they are contributing. And we have done so many questions. Even on oxygen, we have done 2 questions earlier. So how many degrees of freedom are there? 5, na? So you will be 5 by 2 kT. And what is CV then? 5 by 2 kT, that's it. Clear? Clear or not?
Yes, sir.
सर यहाँ पे सीपी क्यों नहीं निकाला गया?
सीपी नहीं होता है जो स्पेसिफिक हीट जब भी हमसे पूछा जाता है तो वो सीबी ही निकालते हैं until or unless वो कांस्टेंट प्रेशर पे आपको बोले करेक्ट क्वेश्चन इट इज ऑलवेज सीबी because CB is directly related to internal energy, not CP. Okay?
ओके सर.
Sir, can I ask you last question?
Yes.
सर इसमें एक्सटर्नल पोटेंशियल दिया था ना और इंटरनल निकालना.
Yes.
बीआर कैसे यूज कर सकते?
Whenever you apply some sort of force on the particle, will there be any change in the motion of the particle or not? Potential means what? Potential means what? Some sort of force is there, na? With which you are confining the particles. Okay? So the particles, they are interacting with this potential. So their internal energy is also changing. Na?
Yes, sir.
So it is a modifier of their internal energy. So their internal energy, it is getting modified according to this potential. So that's why you have to take into account. Na? Clear?
Yes, sir.
Just like, have you studied quantum mechanics? Have you studied quantum mechanics or not?
Yes, sir.
There you might have studied particle in a box problem. So that is the similar kind of problem. Na?
Yes, sir.
Here you trap particle in a box, and inside the box you are having some potential now. So according to that potential, now the energy of that particle it is getting modified. Na? And when you change the potential, then the energy it is getting modified. You might have seen this kind of thing.
Okay, sir.
The potential is external, but still it changes the energy. please try this one. Who has answered till now? It's Divya, Abhay. Yes, Divya, Abhay, Siddesh, Sanju, Arun. It's correct. Yes, yes. A very important point we need to remember in this question actually, that I will tell you. So those who are not able to solve, please note down. Whenever in any question they ask you to calculate the specific heat at high temperature, you have to take into account all degrees of freedom. So till now, we have been disregarding the vibrational degrees of freedom, but at high temperature, they will also contribute to the energy. Okay. So total degrees of freedom are translational, rotational, plus vibrational. So for diatomic, we know it is 3. I think it is not a good idea to calculate F total. Let us calculate total energy only. It is Ft by 2 kT, F rotational by 2 kT, plus F vibrational kT. Okay. So these are 3. These are 2. There is only one, not diatomic. Only one vibrational degrees of freedom. 5 by 2. Not 5 by 2, 7 by 2. So Cv is du by dt. Okay, let me write. At high temperature, vibrational degrees of freedom also contribute. Okay, please check everyone. Clear?
सर वाइब्रेशन तो नॉन रिजिड में होता है ना?
तो यहाँ पे आपको रिजिड बोला है उन्होंने?
कैसे पता?
High temperature, na? I said already that whenever it is given that high temperature is there, you have to consider vibrational.
Yes, sir. Then it will be getting the form of non-rigid type.
Yes, obviously. At high temperature, every molecule will become non-rigid. Now, how can it be rigid?
Yes, sir.
Yes.
Definitely.
It can even melt down. Na? It cannot stay rigid at high temperature.
Yeah.
That's why vibrational degrees of freedom, they contribute at high temperature only. At low temperature, all the molecules, they are rigid only. Vibrational degrees of freedom cannot contribute. It is not a spring that works according to our will. Okay, only at high temperature, the molecules, they vibrate to such an extent that we consider them to be vibrating. Otherwise, they are rigid only. And that temperature is quite high, in the vicinity of the melting temperature of the molecule. And one more thing, there are various kinds of vibrational modes, and they are getting excited at different temperatures. All the vibrational modes, they are not getting excited at the same temperature. This is also one of the things. Okay. So you can take the example of water molecule or carbon dioxide. So what you can do is you can Google it today. Vibrational modes of water molecule, vibrational modes of carbon dioxide molecule. So there you will get some videos, some animated videos, and you will be able to get the idea regarding various kinds of vibrational modes. Okay. Very good, Siddesh, Rita, Smruti, Shri, Arun, Kapil, Divya, Abhay, Jayashri, Tanya, very good. It's very simple. We have already seen. Yesterday we discussed na? Ratio of specific heat is Cp by Cv. And now we are having a shortcut formula between these two na? Relation. Obviously, gamma will be largest when F is least, and F is least obviously for monatomic. Minimum for monatomic. Clear?
Yes, sir.
So you have to consider only translational and rotational. Again, easy question. According to Jayasri, it's wrong. Yes, Tanushri. Siddesh, it's wrong. Divya, wrong. Arun, Kapil, and Jayasri is correct. Everything is given in the question. No, Abhay, it's wrong. It's wrong, Sanju. It's wrong, Monirul. Yes, Tanya, good. Samruti Shri, it's wrong. It's wrong, Dima. Yes, Siddesh. Wrong, Rita. Good, Himashi. It's wrong, Rita. See. First of all, oxygen is diatomic. So for this, F is 5. Argon is monatomic. Degrees of freedom are 3. Now, but there are different number of moles, na? And we have to get the total energy. So U total is U oxygen plus U argon. And for oxygen, it will be 2 moles into 5 by 2 kT. RT, sorry, not kT. Because for mole, na? 4 into 3 by 2 RT. 5 RT plus 6 RT, it is 11 RT. Check it. Please check.
Yes, sir.
Clear?
Yes, sir.
So in this case, first of all, we will have to calculate. No, Smriti Shri, it's wrong. We are mixing the gases. So we have to get CV for the mixture and then CP for the mixture. And then we have to take their ratio. And the formula for that is CV mixture. It is N1 CV1, N2 CV2 by N1 plus N2, where N1 and N2 are the moles. And we have 1 mole and then 5R by 2. N2 is again 1 mole and then 3R by 2. So 1 plus 1, it is 2 now. So it is 8R by 2 by 2. So it is 2R. Now. Please check. Similarly, CP for the mixture. It is N1 CP1, N2 CP2 by N1 plus N2. Now CP1 will be 7R by 2 because CV was 5R by 2. It will be 5R by 2.
Yes.
So now you can take the ratio. So gamma is CP by CV. In fact, in this case, because only 1 mole they were mixed, so we could have calculated CP directly from this by adding R to this because we are doing it for 1 mole. But otherwise, it is not a correct formula. Okay. So gamma will be gamma mixture, CP mixture by CV mixture.
Sir, what is not the correct formula you told?
I said we could have calculated CP directly from the CV also, just as we do for individual gases. CP is equal to CV plus R. So that is not the correct formula. Some of the students, they will try to calculate CP mixture from this by using this formula. Na? So that is the wrong formula. That's what I'm saying. Of course, that is working in this case. And why it is working? Because for both the gases, we are adding 1 mole. Na?
Yes,
If different quantities are mixed, then that formula will give you wrong answer.
yes. Sir.
Okay. So that's what I was saying. So you always have to use this formula for calculation of CP. Okay.
Okay, sir.
So which of the following statements is incorrect? The value of CP by CP plus CB for helium is 8 by 3 for gamma equal to 5 by 3. Now you have to be careful for all the options in this kind of question. Seven R by 2. Now, please try. Incorrect. Kindly check all the options carefully. Yes, Sanju, Divya. No, Tamya. It's wrong. Very good, Tanushri. It's wrong, Abe. Wrong, Rita. Let me do first option for you. I don't know why you're getting the wrong answer. Let me solve the first one. See, for first one, we need to calculate Cp by Cp plus Cv, and gamma is given. So by using this gamma, we have to calculate its value, and we have to check whether it is coming out to be 8 by 3 or not. Okay. So Cp by Cp plus Cv, can I write it as 1 by Cp by Cp plus Cv by Cp? 1 plus, can I write it as 1 by gamma?
Yes, sir.
And gamma is given to be 5 by 3, so it will become 3 by 5. So it will be 8 by 5, so it is 5 by 8. So it's wrong, na?
So MCQ or MSQ?
I don't know right now. Actually, I have not noted this down. And I even don't know from which exam this question is. But
Yes,
perhaps
sir.
I think it is from IIT Jam. And now let us check other options also. But I
Yes,
think
sir.
multiple options may be incorrect.
सर सेकंड में 5/2 r होना चाहिए ना 3/2.
What? Helium is monatomic, it is not diatomic.
Oh,
Okay, it is correct. It is not wrong. It is monatomic. For
Okay, sir.
monatomic, only 3 degrees, so 3 r by 2. So now let us check third option. Okay, C option. No need to check D. So for C, again gamma is given. Okay. So this ratio we have to calculate.
सर करेक्ट है थर्ड.
So Cp by Cv is gamma. So gamma is given to be 7 by 5. Arun, it's correct. You can see. We have to mark the incorrect one. Arun, C is also correct.
Okay, sir.
Now D. Let me check the D option also. For hydrogen, it is diatomic, so it is also clear. It is diatomic, so 7 r by 2. Na? Because F is 5. So Cv is 5 by 2 r. So Cp will be 7 by 2 r. Na? Please check.
यस सर.
Because U will be 5 by 2 RT for 1 mole. Obviously, when they are writing R, it is for 1 mole. No doubt about it. Because only Na into Kb is equal to R. Na? Otherwise, they would have given the options in the form of 80. So clear to everyone?
यस सर.
Sir.
So that's all for today, students. So tomorrow again we will continue. I hope now you would have some clarity over this topic of degrees of freedom and internal energy and CPCV, because we have done lots of questions today. So tomorrow we will discuss some new kinds of questions and then new topic. Okay, of course, related with this only, mean free path and some other quantities. Okay, students. Bye bye. Take care.
Thank you, sir.
Thank you, sir.